Hi, everyone. Hi, I'm Daniel. Most people call me Kid. That's because my last name is Kidon, so it's an abbreviation of that. Also a cool name. I love music, as Candace said. And if anyone wants to jam later or has something, I'm down. Oh yeah, sure. I'm the backend guild lead at Honeybook, and I've been there for the past 3.5 years. And I'm very excited to be here. I'll start off with the agenda, but before that, a joke, because I've told you need to do a joke at the beginning. It would have been very funny if I were late to this conference and came here a little later, because it really is very hard to be on time. So we're going to talk about the challenge of running things, tasks, basically, on time, reliably. Making sure that things that we expect to happen at a certain time will actually happen at that time. And we're going to do that by building up a solution from first principles. So we'll start simple, we'll do the simplest thing that we can do, and then we'll figure out how it's too simple, and maybe it doesn't fit our use case exactly. And we'll build up until we figure out that it's very, very complex, and try to simplify that with using Temporal, basically. Cool. So just a tiny bit, Honeybook, my company, is an all-in-one client platform that takes independents or small businesses from A to pay, which is, I think it's a cool slogan for sure. But in other words, we are a sort of all-in-one tool to help independents, small businesses, creatives to do what they do best, which is being creative and being a part of that business, and not the managing part of the business itself. And this does with working with clients, payments, invoicing, project management, tasks, finances. So it's a lot of different things trying to do handle this issue, basically. I'll keep it simple. This is a very, 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 very simplified tech stack. Basically, an API running on Ruby on Rails. We have a Ruby on Rails monolith, generally speaking, and there's lots of other services. But yeah, Ruby on Rails, Redis, Sidekick, MongoDB as our database. And we have an application that uses this API and other applications. So generally, yeah, Ruby on Rails API. We use Sidekick for synchronous jobs. And we use MongoDB to store state. So let's use a use case, a product use case, to get this rolling, right? The use case is project recaps. So what we want to do, what we've wanted to do, is send members a project recap to share with their clients before meetings. And this would be Gen AI generated, where we can give them summarizations of the communications that they have with this client, maybe things, former tasks that we used to have, and their status. Some of this would be Gen AI, really, and some of it would just be state, in a certain way. But that's what we want to achieve. So basically what this means is that we want to do something at a certain time, and that time is based on specifically a meeting. So before a meeting happens, I want to send out a recap. How do I do that? Let's start simple. The simplest thing, we know that the model has a date property, meaning I can just ask the database, give me everything that should be running right now, and I'll try to run it, right? So we'll poll the meeting collection on date and queue jobs over time. But it's a little too simple. Why? There's lots of inefficiencies of the polling mechanism. It can create load and scalability issues. It's hard to do this distributedly and promise that things will actually happen the amount of times that I want them to happen. And it's use case dependent, as in a meeting could be one thing, but maybe we have another collection that can also generate the same recaps, and maybe would have a different use case that we haven't talked about right now, which sends us to what we change this into, which is scheduled jobs. So the idea is there's a thing that needs to happen, a unit of work, a job. This unit of work could be scheduled to happen at a certain time. So in a day from now, in a week from now, an hour before something else happens. Those are all timed and scheduled jobs. So a little about jobs. Because we use Sidekick, it's important to just understand the technical aspects of what it makes us do, or like the constraints that it can put upon us. when we try to do this change. So jobs are just JSON. Basically, they're all the arguments that a unit of work might need in order to be able to run. It uses, generally speaking, it uses Redis, because that's what Sidekick does. And Sidekick also tells us that it's simple. What does that mean? It does exactly one thing. It runs jobs. That's the idea. So the implementation details of it don't try to help us succeed in certain things, like getting things done on time reliably. But we do have some sort of solution. So what we do is, if we want to enqueue a job right now, so something that needs to happen right now in a synchronous job, we just do that. We have a queue, multiple queues in Redis, and the values in the queues are just the job itself that needs to be running. So it's the arguments that we want to run later on. And if it's a timed operation, meaning it's something that we want to happen at a certain time in the future, we went about this way where we have a sorted set in Redis, which was basically just a list of jobs that are sorted by the timestamp in which they need to run. And what this enables us to do is, what this enables us to do is to look at a window of time and to be able to ask our sorted set, give me everything that should be running at this point. Why is this a little better than what we did before? The window of time, and because of how Redis as a in-memory database works, is that it's easier, it's faster, and it's more efficient to look at a window of time based on this timestamp and be able to take the jobs and just do them. And now it's very simple. The value in the sorted set is the same exact JSON that you would see in the queue, keeping it very simple. What does that mean? When the job is its time to run, we take that same value and just enqueue it into the jobs. And now we have a job that's supposedly going to run, and we are trusting in our infrastructure, trusting in Sidekick that this job will actually run at a certain time, like the next possible time that you could run. The issue with this is that we forgot something. What did we forget? We forgot that meetings can be canceled, meetings can be rescheduled. So this timestamp that a job has right now and needs to run at a certain time can change. And can change depending on many different things that might happen to that meeting. And many different interactions that could change the date and the data around that meeting. So looking at this again, we have an issue where it's hard for us to find, to remove or cancel or change a member of the sorted set. So right, we entered like a list of all the things that we want to happen at a certain time. But now we want to change that time, and we need to find that record in Redis and change it. The thing is, we kept it very simple, right? So we only have the JSON serialized string that represents the actual job that needs to happen. It becomes very hard to actually be able to find this job at scale, right? Because we need to go over basically all the jobs and find this job specifically and be able to change its value. So what we did with this is like, okay, we have a job, we want it canceled, we're going to use a separate index to do that. So we now have like a canceled index, right? So this canceled index would just say, this job shouldn't run at a certain time. So when it does get enqueued, it just doesn't. We discard it before it's enqueued because it is canceled. And rescheduling is, we also kept that simple. It's just cancel and do it again. So it won't run when it's supposed to run. It'll just run at a different time, the time that we put. Basically, it's the same job twice in that sorted set. But then we had production. And what happened? Occasionally, users would report that they get their project recaps at the wrong time. So wrong is in exclamation marks because it might be almost right. What does that mean? It could be just before the meeting that they did have before they were scheduled. So it's a time that does make sense, but it's not the time that they're expecting because they changed the meeting, right? So what this led us to understand is, okay, different things can change our job, right? Different things can create jobs and change the data, and all of those things are like units of work that need to happen. Something needs to run in order for this new job to be able to be there. We need to create a new job. put it inside that set, be able to cancel the old one, all sorts of things that need to happen. So we can promise, in some ways, atomic operations using scripts with Lua or any other thing with Redis, but still things might not happen, right? Something might fail, we might not get the new job ID that we are expecting, and something just doesn't work. So we say, okay, this is a problem. And why is it a problem? Because we have very, very low visibility on what we intended to actually intended to happen, right? We have this index of jobs being canceled and this place where we save jobs, but we don't manage the state of things being changed. And what that led us to realize is that when we get those production issues, it is very hard for us to explain why, and even to realize for ourselves, not even for our customers, why didn't it run at the right time, or what exactly is the right time that it should have run. And that created a lot of issues. So we understood that this execution of a job, this thing that needs to happen at a certain time, that has state as well, and that state is really important to understand. So what would that be? Those would be audits, so basically the things that are changing, what changed. Like, I want to know that this job was scheduled for a certain time and then rescheduled to a different time because I want to understand this. And then we also want to understand if it actually did run at that time when I wanted it to run, and if it didn't, when did it run, how did it run, did it fail? All this information, it was available to us via logs. We could look at the data at certain points in time. We can even restore data from a backup and see what it should have been at a certain time. But all of those things are, they're pretty hard. And they're definitely not fun. And for sure, they impact velocity. So we couldn't do things very fast when we wanted them to be on time, which is counterproductive for things being on time. Yeah. And another thing about that is that meetings can also be really, really far in the future. We've had people make yearly meetings with their customers. Our customers have customers, so we're a B2B2C kind of operation. So our businesses that are our customers might have things happening in 2038. This could be a wedding, it could be an event, it could be a job or a project that should end someday in the future. And we might want to be able to send them recaps. This also creates an issue where using that one sorted set creates even more problems. Why? Because it becomes very clogged. It eventually becomes huge because we have lots and lots and lots of jobs that we will probably never even reach. Well, I hope Honeybook will still be running amazingly well in 2038, but most probably not using Sidekick. I'm just assuming. So looking at this, it's also very hard for us to migrate and change because we have jobs scheduled in the future in some time that we're not even sure if they're supposed to run or not. It's hard for us to look at all the jobs and get visibility on everything that should be scheduled in the future, and it's problematic. Yeah? So that pushed us towards doing something that we called Updatable Timers. The name Updatable Timers might be, you might have seen this in the Go samples for the Temporal SDK, where there's just a Go file called Updatable Timers. So it's kind of we did this a little before we saw that, but it's very similar in its ideas. So we understood that we need some kind of orchestration state. So we have a unit of work that needs to run at a certain time. We should probably save stuff about it. We want to know what the changes were, how the execution status is, what's been changed, when did it actually happen. And we also got a few software engineering things going on from having this thing. So we have a place for state, which is important. We need this. The other thing is we have clear boundaries. What does this mean? If we up till this point, we kind of use Sidekick very directly. So we just enqueue jobs. We enqueue jobs for a certain time, but we did this in a very low-level spec. And Updatable Timer lets us say that something needs to happen at a certain time without worrying about how it's going to be happening, right? So the implementation of Sidekick actually creating jobs and putting those jobs in places and canceling and updating all those things, those are not, our developers don't need to be able to see them in order to get the promise that something will run on time. And this actually helps us with things that I'm going to talk about soon, but it's been very nice. And the other thing is that it's more versatile in that we can decide, because we don't show how the implementation actually happens, we can decide to change that implementation depending on different things. Like, for example, we said 2038 is a very far in the future kind of time, right? Maybe we shouldn't schedule things for 2038. Maybe this model is enough to explain that this unit of work should happen in 2038. And then we'd only schedule this work closely or more relatively next to when we actually need to make it happen. And this lets us be able to query the state, be able to see all the updatable jobs, and also to be able to change our implementation depending on the use case in the best way that we can, basically. Then we want to grow, and we want to go fast, and we want to be versatile, and we want to serve millions of active users reliably. And that's a little hard. We still have complexity issues with the solution that we have right now. We have a lot of state telling us what's going on, but what's going on isn't exactly what we want, right? We still have jobs being late. We still have jobs sometimes not working. We now explain it better to ourselves, and maybe we can migrate them and fix it in some ways, but not always and not usually. And not usually because when something hadn't happened at a certain time, that time has passed, this is it. It's not relevant to us anymore. And complexity grows as we use multiple databases, which creates all sorts of issues with, is the data the most updated it could be, and all the usual problems that they know about this. Redis as the engine that holds everything that we're going to run isn't something that could scale indefinitely forever, and we'd probably need to change the ways that we save things. And also, we're missing a few guarantees at scale. Guarantees as in when things run, why they should run, exactly once, at least once, those ideas. It's hard for us to actually guarantee, both for ourselves, our developers, and our customers, that these things are actually really happening as we're expecting them to be, which creates all sorts of, even if in the engineering day-to-day, this complexity creeps outside of the abstractions that we created, and now the developers usually need to handle this situation. So for example, they need to check things like, maybe it didn't happen, or we can't expect things to happen as we told them to happen, meaning we need to do more work, right? We need to do more checks to see if state makes sense. We need to validate that the thing can run at a certain time. Maybe if the latency is very high, we decide not to send the recap at all. And each of these are use case dependent, right? So every use case would have its own thing. And we'd rather this complexity not be part of the day-to-day that other developers need to think about in order to achieve their product goals, basically. And that kind of brings us to a thing. If you might have noticed this building up, that over time, this solution that we've built has took us to a way that's more and more temporally. What do I mean by that? Oh, we realize things. We realize we need state. We realize we need guarantees. We realize we need distributed operations. We realized all these things. That sounds familiar, right? It sounds like something we're all talking about a lot here. This is from the actual Go SDK samples, right? This is an updatable timer. In other words, basically, it's something that can run a unit of work, and this unit of work will run at a certain time, and this time it can be changed, can be updated, and can be canceled. The state is saved, right? It's queryable. I can find all the updatable timers that I would want to find and have a certain execution happen. And it just, gives a lot of what we were talking about before. I didn't do more than this. I didn't do like a code example of how actually updatable timers work for us, because generally speaking, we showed an abstraction before. It's not just the project apps. It's not just that use case. It can be anything that we work on. And looking at this got us excited, right? We looked at this and we're like, oh, yeah. That's exactly what we wanted to achieve. And this shows how simple it is to abstract away these concerns and just trust in an infrastructure that actually gives us these concerns. Yeah, so it was a little shorter because I speak very, very quickly. I know this, but if anyone has any questions, it's a good time. I would like to, before I go into that, is just I conclude that it's very difficult to build these things, and usually at Honeybook we try to do the exact thing that we need to do to get our product. We're not purists trying to find the best software. We're mostly just trying to get our solution out there in a way that's reliable, right? And that's why we kind of build this slowly but surely, always fixing the issues that we care about most. And it's gotten to a certain point where if we need that extra layer, we basically need Temporal to give us those, added benefits. Yeah, questions, if anyone has them. Yeah?
How have been your integration process between systems?
Integration process between systems? Migrating. It's a great question. The question was, how was the migration process between having just jobs and having this updatable timer? It was relatively easy because the idea is that the timer doesn't actually do anything. It's just state, right? So generally speaking, in order to be able to have this model and have it pointed to a job, all we kind of need is the reference to that job. So we can create a state that tries to follow, what the job is, and then we just tell it, this was your job, as if the updatable timer had already implemented, putting that job into a queue. So relatively, it was pretty simple. Yeah, definitely. Yeah.
How do you handle recurring events? Like, how do those get measured?
That's a good question. Sidekick does have a solution for recurring events, where it's like a cron kind of thing. You set up times and something will run. But we did find lots of issues. I didn't go into them here with actually promising that these cron jobs will actually happen on time. It's based on this tick that happens every once in a while, and this tick can fail for certain reasons. And then if it fails, that thing will just will not work. So solutions could be running it twice, but then asking if I already ran today and not actually running it twice. We've done that before. And then we, over time, just ported the whole solution to using a different kind of set of updatable timers. It's still an updatable timer, but it has like a bit of a different metadata to it. It's kind of similar to how, well, not as robust, but very similar to how schedules happen in Temporal, basically. Yeah. Any other questions? Okay. Well, thank you so much. I enjoyed this a lot. Thank you for being here and coming on. Really, it's been a really nice couple of days, and yeah, thanks.